Okay, so welcome to today's lesson, and today's lesson is we title it Advanced Data Analytics. Yes, at this level it is advanced, even though advanced continue. There is no end to advancement, so keep advancing. So basically, these are the things we are going to be looking at in today's lesson. The basic things we'll be looking at in today's lesson, like we have said that the title or the topic is advanced data analysis, and we have simplified it. So what we learn today is we'll learn what data transformation and why it is important. We also see how we are going to ensure accuracy in our data analysis, and that's what we're looking at validity. Then we'll also see how we can ensure consistency, and that's the aspect of reliability. Then we'll talk about basics of hypothesis testing and understanding errors. Then we'll look at key statistical tools like the t-test, the chi-square, the correlation, the ANOVA. Then, although regression is not part of the, this curriculum or this training, I didn't put regression in the timetable I included, but then I'll just see it as a bonus that I'm going to include for those of us who really need it for maybe our postgraduate studies or for some other area of research. Then throughout, we'll try as much as possible to see practical examples and real life application of some of these things we'll be talking about. So please, as we continue, once you notice anything or you have any question, you can drop it in the chat, in the WhatsApp chat, or in the comment section. Someone will attend to you. Even if I can't attend to you directly, definitely somebody is going to attend to you. Then the next thing we'll be looking at is just to go straight into what we have for today. So the first point of call is variable and data transformation. Yesterday we have talked about variable as what we measure in our research or discussion. So variable transformation just involves altering the scale or form of a data. And a good example is if you collect data about height, and when you are collecting the data, you measure the height in inches. But then in your analysis, you need to use centimeters. So what you need to do is to what? Convert it to centimeter. That's the kind of transformation. So you have transformed the variable. You collected it in inches, but now you are making it in centimeter. Or you can talk of temperature. Maybe you collected temperature in degrees Celsius, but then you need to use this reading in an analysis that has to do with an American. I know in American they measure temperature in Fahrenheit, so you must have to convert the Celsius to Fahrenheit. So that's transforming data. So you can see like a conversion for those people who are in the field of science. You can term it as a kind of conversion, and you can do this in XPSS directly. You can also do it in Excel directly. At a click, you can do for 1 million or 1 million values. Just one click, it will do 1 million value conversion or transformation for you. Then data transformation, we can look at it in 4 ways. One, aggregation. Now in aggregation, you are combining the data into summary measures. For example, now every day you are selling something and you are taking down the record of what to sell every day. You can now do what you can aggregate all the daily sales data together to obtain monthly totals. You can also you can do it again to obtain yearly totals, or you can do it quarterly, then yearly. Then you can do it maybe in a decade. What have you been able to sell, or what have you been able to achieve? That's aggregation. Then normalization, like you are scaling the data to a common range, maybe between 0 and 1. And this is very common in the field of academics, those who are in education. Our grades is always from 0 to 100. So you can use it to compare different scales. Like they will tell you that this person is A star, is within the range of A star, the range of A, B, and so on like that. So, but the boundary is 0 to 100. That's like normalization. You are putting it within a boundary. Then you can look at data generalization. In this situation, you are grouping data into categories. For example, you have range of ages. You can now classify them based on how old they are. You can have maybe infant, toddler, teenagers or preteens, then you move to adults and things like that. Or you can just decide that, okay, this data I'm using is not involving children, so we just group them as either youth or an adult, or is a young adult and older adult. So that's also a kind of generalization. Then the next one is data smoothing, and this is I consider this as one of the most important parts, because it's more like you are trying to clean the data. You are removing inconsistencies, you are removing things that are we can consider as outliers. So in this situation, you can just, okay, let me use an example of this data smoothing. You can think of maybe you are taking a record of, say, maybe temperature, and maybe by mistake the thermometer malfunction, and during the day the thermometer is now measuring at a particular time, is measuring a temperature of 70 degrees Celsius during the day. Then that is inappropriate, that is an outlier. So you have to correct that, you have to fix that inconsistency, because it's not possible. So that is correcting outlier. So all these things we talked about, they are just like what do we call it now, we can refer to it as data cleaning. Yes, data cleaning. You have to do this before you start doing your um analysis, and it's very, very important. Please, I hope this point is gotten by everyone. If you have gotten this point, let me see a thumbs up. If it's not, if it's not if this is not um confusing, if it's very clear to you, you can just give a thumbs up to that. Okay, we can now move forward. Thank you very much for that. So now, validity and reliability. This aspect is very, very important. For those of us who have done research, maybe in our undergraduate and postgraduate, you see that it's a very important aspect of our research. And what is validity? This one refers to like the accuracy of a measurement. Like what I'm trying to measure, is it accurate? Is it measuring what it intends to measure? Okay, I want to measure, for example, I want to measure the height of a table. The tools I'm using, will it measure the height for me? And we have two types of validity. We have the criterion validity. It asks the question, does the test predict an outcome? We also have construct validity. The question it asks is, does the test measure the intended concept? You want to measure mass, but then you are getting value for volume. Will you be able to use volume to get the mass? Is it mass you want to measure or volume you want to measure? Is it intended for that? Now you want your test to predict an outcome. So what you are doing, is it going to actually predict the outcome that you are expecting? So these types of validity are questions they will ask you if you tell to if you want to like maybe defend project, or you want to present some key points in your research, or whatever you have done for people to check out for. So you have to make sure that the what you are measuring, the data available to you, is accurate, and it's going to measure the exact thing you tend to measure. Then reliability. This is talking about consistency of results. A reliable measurement yields consistent results over repeated trials. A reliable measurement yield what? Consistent results over repeated trials. So for example now, if me as a teacher, I test, maybe I carry out a test on class A. I have taught class A a particular topic, and I carry out a test on that class A. If I carry out the test on class B, who were the and I have also taught class B the same thing, will I get consistent results? Or if I give tests to different groups of people, will the result I'm going to get be very consistent? So that is talking about reliability of the test. So please, can I just have a few seconds to just give me a few break. I'm going to get back to you in a moment. Please, just a few break. I'll get back to you in a moment. Let me pause it so we can continue from where we stopped. So I was talking about validity and reliability. So we talked about criterions validity and construct validity. So if you look at the aspect of criterion validity, okay, I think I've left that aspect, but then let me just give you a very good example of criterion validity. Now, we said for criterion validity, does the test predict an outcome? Say, for example, a fitness test. Is it going to predict accurate athletic performance? If somebody who is doing sports, if the person is carrying out fitness tests consistently, will that help to predict if the performance will improve or not? And that is criterion validity. Now, when it comes to construct validity, you are looking at, is the test measures what you intend to measure, what the test intend to measure, is it measuring it? And in that situation, I can give an example of maybe somebody okay, maybe a mental health questionnaire. If you want to administer a mental health questionnaire, like a questionnaire that has to do with people's mental health, that means it must contain some kind of measurement like stress, anxiety, and maybe resilience and things like that. So those are questions that has to relate with what? Mental health. So if you are measuring anything, to be sure that that thing is valid, you must make sure that it is measuring what it intends to measure. I must also measure that it contains the question that will relate with what you are measuring. Then for reliability, we've talked about reliability as like it has to be consistent. If you use it over and over, it should give the same result. We have internal reliability. Are the questions consistent? Then inter-rater reliability, will different observers get the same result? So for example, I give we set a math question for students. First teacher who has taught maths the same topic to a student gives the maths question. Another teacher who has taught the same topic with a student, if you give the maths, if you give the question, will will it measure what he intends to measure? And exam bodies, their exam bodies reliability test must be very high, because students all around the world and in different area, they have been able to expose themselves to their curriculum. So the question they must bring must be a question that every one of them must be able to attempt. When that happens, we say that the test is what? Reliable. Then there's what we call test retest reliability. That is to say, if you give the same test over and over, will you get the same result? It may not be the exam's same result, but then the result you are going to get should not be very far from it. So all these ones relate to validity and reliability tests. Then the next thing we'll be talking about is hypothesis testing. Testing hypothesis. Now, from our normal question, the hypothesis just is a claim, like a reasonable guess, or it just somebody have an idea and is suggesting something. So we can just test if what this person is suggesting is true or false. And that's what we'll talk about hypothesis testing. Now, there are two types of hypothesis. We have the null hypothesis. Null hypothesis is more like a default statement. Like, just make a statement that um over about something. Look at the example that is given on the screen. There is no difference between boys and girls test score. That's an hypothesis. There is no difference between boys and girls test score. So this is default. So now you can carry out a research to now confirm if this statement is true or false. And that is where statistical tools comes in, which is part of what we are going to talk about tonight. Then there's also alternative hypothesis. This alternative is just the opposite of null hypothesis. A claim that opposes the null hypothesis. For example, now girls score higher than boys. So you can see that the first hypothesis, the null hypothesis we stated, said that there is no difference between boys and girls test score. But now the null hypothesis, sorry, the alternative hypothesis is now telling us that girls score higher than boys. Now all these are just reasonable guess. We can now subject them to statistical calculation, which will help us to do what? Which will help us to be able to know if these statements are true. So at the end of it, we can now say the hypothesis is accepted or rejected. By next lesson, we will be able to do this practically. We'll have data, we'll state hypothesis, and we are going to use SPSS to test the hypothesis for each of the words, each of the statistical tools we'll be talking about. Then the next point is parametric and non-parametric text. This one we talked about it faintly yesterday. So let me just quickly put more light to it compared to how we talked about it yesterday. So now we said parametric tests assume that the data follows a normal distribution. I want to talk about normal distribution. We are saying that the data or the data in this situation is like it is what you expect on a normal day. What you expect on a normal day. And whenever you want to do analysis, you can decide to choose any of these tests, maybe a parametric test or non-parametric test. So when the data is normally distributed, we follow parametric tests. So they are powerful but require specific condition. An example of that is comparing exam scores of two classes in a particular subject using t-test to check if there is a significant difference. So this is example of parametric text. So take note, parametric text assume that the distribution, the data distributed is normal. That is to say, on a normal day in a class, you are going to get smart students. Maybe if we have a class of, say for example, 100, 20 will be very smart. That's an assumption. That's the normal distribution. 20 will be very smart. Around 60 will be average, and the remaining 20 may be maybe below average. So that distribution is kind of normal. Or you can say 10 will be very smart, 80 will be average, and 10 will be below average. That's a kind of a normal distribution. So that falls under parametric. But non-parametric test is flexible. So now they don't rely on assumption about the data distribution. They don't rely that okay, oh, this is what is probably going to be, and they are suitable for what we call unusual data or skew data. So it's more like you are dealing with students individually. That's a good example of it. So you are ranking students without using any of their, or without taking note of their exam condition, or you are not looking at their specific score distribution. That's non-parametric text. So let me give this illustration. Imagine we have two doctors. If we have two doctors, one assumes all the patients are the same, and because that one assumes that all the patients are the same, he will prescribe the same drug for them. So whenever anybody comes and say I have headache, the doctor will give paracetamol. Whenever another person comes says I have headache, the doctor will give paracetamol. If another person come he say I have headache, he give paracetamol. So in that situation he is doing parametric test. But then we now have another doctor. Somebody comes says I have headache, the doctor will not just give paracetamol straight. The doctor will look at it critically based on that person's situation. Maybe the person just need to go and sleep and and the headache to go off. Maybe the person needs to just take water and the headache will go off. Maybe the person needs to just take something sugary and the headache will go off. So the doctor is now treating it based on that individual's characteristics. That is what? That is non-parametric. Please, do you have any question about this, or it's reasonably explained? We can't explain everything completely, but then at least substantially should be able to grasp the point we're driving at. I don't know. Do we have? Is this okay for us to continue? So let me get signals, please. Okay, thank you. Okay, please, what's your question? Maybe you can also drop your question in the chat box if you are comfortable with that. If you can drop your question in the chat box if you are comfortable with that, or if you can speak out.
Okay, sir. Good evening, sir.
Good evening, how are you?
I'm fine, sir. Sir, concerning the parametric and non-parametric test, is it possible that we can have data that can require us to use both tests at once, or you must use only one?
Yes, is a possibility. That's why we talk about data transformation. There are situations where we might have to transform data so that we can deal with a particular transformation in a parametric test way. I will deal with another set in a non-parametric test way. So it's a possibility. I don't know if I've answered your question.
Yes, sir. Yeah. Thanks, sir.
Okay, thank you. So if you have any question, it's okay for you to call my attention to it, or you just drop it in the chat box. So let's move to the next thing quickly. Common statistical test. Common statistical test. We'll be talking about all these common statistical tests we'll be talking about. We are going to use them practically with SPSS on Friday and Monday. And I want to please emphasize here. I want to please emphasize here. If you did not complete all your assignments, there will be two certificates. There will be certificate of attendance and there will be certificate of completion. So it is only those who complete all their assignments that will get certificate of completion. So if you just paid for this seminar, you just attended, you did not complete your assignment and task, you will get certificate of attendance. Please. So please, I want us to be serious with our assignment, and that's why it is like that. So two certificates, certificate of attendance and certificate of completion. So every time I speak or in the group, I will be explaining that consistently. So another question is in the group says, please, what statistical tool is required to do non-parametric? An example is a chi-square. So we are going to get to that point too. We are going to get to that point too. So if it's about SPSS not opening on your system now, we'll treat that later. After this lecture, I'll wait a while to attend to some of us who may have issue with who have technical issue. So after this session, I will answer technical issue questions. So if it is not technical issue, you can keep it till after this seminar or training, as the case may be. Thank you very much. So let's move on to common statistical tests or statistical tools. There are a lot of statistical tools. We have the t-test, we have ANOVA, we have chi-square test, we have correlation test, we have Friedman test, we have Smirnov test, we have Fisher's exact test, we have so many tests. But for the purpose of this training, we will be emphasizing the ones that are mostly commonly used and over time that I know that in the field of research and business, they often use it very well. Those are the ones we are going to emphasize on. And if you look at the schedule of activities, I included them there so that we'll be able to understand what we'll be learning. So the first one we are looking at is correlation. From the word correlate, a lot of us have been using this word normally in everyday language, everyday expression. We use the word correlation, maybe just casually. Maybe somebody, if you are discussing with somebody and another person just jump into the discussion and the person deviated from what you are talking about, you'll be like, what are you saying? What's the correlation between what you said and what we've been talking about? You can see that you have an idea of what correlation is. So correlation measures the relationship between two variables. That's what correlation does. It measures the relationship between what? Between two variables. So if you have variable A and variable B, correlation wants to see what is the link between them. Is there any link between them? And basically there are two types of correlation. We have the positive correlation. It simply means that both variable increase together. Example, more study time most likely determine higher exam score. More study time determine higher exam score. That is um, positive correlation. Then negative correlation says more exercise, lower weight. You can see because somebody increase something, another one is decreasing. So you can also look at correlation in terms of variation, like we learned in mathematics. There is inverse variation and direct variation. Direct variation, one increase, the other increase. Inverse variation, one increase, the other goes down. So positive correlation is like direct variation. Both of them increase or proportion as the case may be. The negative correlation is inverse proportion or inverse variation. As one increase, the other one goes down. And there are times there will be no correlation. There will be no correlation. Like the example I gave, we're talking about maybe we are talking about let's say we are talking about business, how to start a business, and how business can be very very important in Nigeria of today. We are talking about how everybody must be involved in different streams of income, and that's what we hear all around the world, that you must have different streams of income. Like we're having this kind of conversation among ourselves, and somebody just come in and bring in religious issue. Everybody will look at the person. What's this one saying? It's far away from what we're talking about. So somebody among us will now say, what are you talking? What are we saying? What you're saying is not even correlating or relating with what we're talking about. So that's example of how we can relate, or we can see correlation. And there are different types of correlation, like statistical tools correlation. We have Pearson correlation. Pearson correlation is for linear relationship and is one of the most common. Is one of the most common. So for linear relationship, trying to see how two things relate with each other. Then Spearman rank correlation is for ranking or non-linear correlation. Maybe you want to see how position correlates with different things in a classroom. You can use Spearman rank correlation. Now let's look at this graph to have more understanding of correlation. Look at the graph. So if you look at the graph, the first graph where we have P equals to -1, that tells us that there is a negative correlation. And generally in correlation calculation, you may need to take note of this. The value of correlation is usually between -1 to +1. That's the value of correlation value, between -1 to +1. So correlation is always, the value of correlation is always between -1 to +1. If the value of correlation is 0, as you can see in the last graph here, where P equals to 0, it simply means there is no correlation. If the value of P, that's correlation, is -1, it shows that there is a perfect negative correlation. But if the value is +1, that's a perfectly positive correlation. But if the value is between 0 and +1, that's a positive correlation. And the value is between -1 and 0, that's a negative correlation. So correlation strength is always at the end of the values, in the sense that if it is -1, that's the strongest correlation. If it is from the strongest negative correlation. If it is +1, strongest positive correlation. So about correlation, I want to find out, do we have any question from anyone about correlation? Oh, if you can't see the graph, please, is there any one other person who cannot see the graph? Who else can see my screen? Please let me know. Please try and refresh if you can't see the graph. I want to assume is network issue from your end. Please kindly refresh if you can't see the graph. I want to assume is network issue from your end. So if there are no question on this correlation, can I get signal to move on, please? Thank you very much, sir. Thank you very much, sir. If you think I raise a point that need to be corrected, please, I'll be glad to to note that. If you think there's something I said that you didn't get well, or that you feel is not relating to what you know before, please, let's talk about it so that we can be able to reach a very good point. Very very important. So now let's move on. So the next point of call is, in a moment please. Okay, I think my PowerPoint slide is not. Okay, sorry, please let me try and reshare my screen. Stop, reshare so that I'll be able to. Um, okay, good. Okay, it was hanging before. So let me go back quickly now. So once I share now, please kindly indicate if you can see it again. Please indicate if you can see my screen now. Please, can you see now? Thank you very much for the presentation on this, for that comment. I appreciate you for that. Thank you so much. Okay, fine. So let's quickly move on to the next statistical tool. Okay, the next statistical tool is t-test. So t-test is a popular test that we use to compare two groups, and it's really very popular. It's one of the statistical tool that I like and I enjoy doing. It's very easy and very sweet to interpret. Now, for t-test, we are looking at two groups. You want to compare how two groups are faring. Now, we have two types of t-test. We have the independent t-test and we have the paired t-test. Now, an independent t-test compare the means of two unrelated or independent groups. Two unrelated or independent groups. For example, we could use a t-test score to compare the exam scores of two different classes. Like there are two classes and we want to compare their exam score. So maybe we have class A and B. We have done their exam, maybe they have done their exam in chemistry. Now I want to compare the exam score so that we'll be able to know maybe the class are at the same level, or maybe there is a class that is stronger than the other class. We want to check if there's a significant difference between the average in the class and the average in the other class. So you can employ independent t-test. Now, for us to use all these statistical tools, there are conditions, and those conditions we'll be looking at them once we start applying them. One of the conditions for this independent t-test is that whatever you want to test must be a continuous variable, like a value that continues, not discrete or not categorical. We are going to talk about that. Let's not be disturbed about that. As we continue to mention some of these terms, we'll look at them practically. So that is for independent t-test. Then we have the paired t-test. I'll give illustration after this explanation. So after that, if you have question, you may also raise the question. So we have a paired t-test. Now, the paired t-test compare the means of two related groups. For example, we could use a paired t-test to compare student test score before and after teaching a new method or using a new teaching method. Okay, I use paired t-test in one of my master's projects. One of my master's projects, I was comparing, I was looking at student score. Okay, I was looking at retention. I used a particular method to teach a group of students. After teaching them, I collected their scores. Then after collecting their scores, I waited for okay, I collected their score before teaching them. I collected their scores after teaching them, and I now collected their score again after 2 weeks, and that's to know the retention. So I want to check if there's a difference between this retention score and the score they got after teaching them using that particular method, and I have to use this peer test. So score before and after using a new method of teaching. When you try to compare, if there's a significant difference between them, you can use paired t-test. So now let's look at an illustration to help us understand more about the concept of t-test. So think of maybe weight loss program, maybe those who are doing campaign or advertisement, or maybe someone just brought a weight loss program, or someone just brought a weight loss product that is coming into the market. The person can prove to people empirically that it is actually working. What would the person do? The person will weigh the participants before exposing them to that program, or before asking them to take the maybe the drug or the supplement, weight loss supplement. So you measure the weight before taking the supplement or before enrolling in the program, maybe a gym program. Let's use a gym program for example. So now, after you have what after you have exposed them to that gym program, or you have exposed them to that supplement, weight loss supplement, you also measure their weight again. So after doing this, you now carry out a paired t-test to check if there is a significant difference between the weight before and weight after. And with that value, you can tell people that yes, there's a significant difference, or people can crack you down and say, oh, your product is not working. There is no difference before and after enrolling in your program or taking your supplement. So that's another way you can look at t-tests. So I don't know if this makes sense to us, or someone has question about the concept of t-test before we move forward. Thank you for the comment. I really appreciate. Okay, fine. I guess we are moving forward and it's making sense to us. Now let's move to the next point of call, and that is ANOVA. ANOVA, also known as analysis of variance. ANOVA, also known as analysis of variance. Now, ANOVA is comparing group averages to see if differences are significant. So ANOVA is just like the senior brother of t-test. Now, t-test is comparing two groups, right? So ANOVA is comparing more than two groups. That's the way I used to explain. I say that to myself, that t-test ANOVA is just the senior brother of t-test. So you compare group averages to see if differences are significant, and there is one way ANOVA. So one way ANOVA, you are using one factor. Take for example crop yields using three types of fertilizer. You use three types of fertilizer. What is the effect of these three fertilizers on crop yield? So you can see that in this ANOVA now, we are using more than two things to compare or to see how it affects the first one. So in this situation, you look at the product crop yield before using these three fertilizer, then crop yield after using these three fertilizers. Then you now compare the average. So that is one way ANOVA. Then two way ANOVA, you are comparing two factors. For example, how gender, I can see gender now is what? Male and female. Those are two factors. But the first one way ANOVA that we talked about, we have crop yield. Crop yield is just straightforward, one factor. So, but now the second one, two way ANOVA, we have how gender. In the instance of gender now, there is male and there is female. So you can see that two things are coming. So how gender and education level affects test score. So you can see gender is coming in. Two gender, we have two categories there. Then education level, we can have more than three categories, like maybe SSC holder, a graduate, a master's holder, a PhD holder. You can see that we are using so many things to compare them now. So that's a two-way ANOVA. All these things, like I said, we are going to use the practical method using SPSS to explain each and every one of them. And I want you to prepare our mind. Everybody will do something. At least you'll be able to use 5 of these tools. You'll be able to, like for my assignment, or for the assignment I'll give to you, you'll be using like 5 of these tools practically, and you're going to share your results for me to see. And you will be able to do it anyway, because I'll be on ground to guide you and to support you in every step of the way. There is also analysis of covariance. Is beyond the scope of this particular training we are doing. Subsequent training, maybe if we'll be organizing subsequent training for this cohort, we'll be doing something higher than what we are doing so far. So may I know if there's any question on this and over before we also move forward. If there are no questions, you can give me signal for us to keep progressing so that we can finish up quickly. This is 8:50. Once there are no questions, just give me signal for us to move forward to the next point of call. Okay,
Okay,
thank
sir, please, can I ask a question?
okay, thank you. You can ask a question.
Okay, based on the two-way annual, you said
Okay.
comparing two factors. Now, looking at the example you gave, how gender and education level affect test score. So, are we saying that we're going to like? I'm just trying to like do a kind of recap. Let me follow with my understanding and see what I'm understanding is exactly what you are passing on to us. Now, the gender scores, for example, giving the male scores, female scores. So, are we going to like maybe to add it, add them total, then now divide by total number of male scores? Is that because we're talking about average now? Is that what you are looking at?
Yes, you can. If you look at it first, on what is on top, Hanover compares group averages. Miss Favor, did you see that
Okay.
group averages, right?
Yes, I got it. I got
So
it. Yes, sir.
I think that settles your question, right?
It means, okay, that means the average of each of the group
Exactly.
we now
So we now
compare.
yes, that's what we're comparing, and it's exactly the same thing for t-test.
Okay, thank you so much.
You're welcome. Okay, Mr. Isaac, you can ask
Okay.
your question. I see you said you have a question. If you have question, please ask on your mic and speak out. I guess Mr. Isaac said he has a question. Okay, you said you need more examples, right?
In a more detail, the example you gave for that one way and over.
Okay, so you want something more detailed, right? Okay, let me figure out what else I can use to talk about these one way and over now. So now looking at this, we said crop yields using three types of fertilizer. Okay, let's use marketing as example now. So let's say you want to find out um, what will make buyers come to you. Is it online advertisement? Is it sharing flyer? Is it what else? Is it customer referral? So if you want to use these three factors to see how these three factors will help, um you want to see which of these three factors is helping you to get more customers, you can also use one way and over. You can see it in that light. I don't know if that makes sense. For example, now one of the questionnaire I gave to Ross, and I don't know if it is this group. I One of the question, can I remember the question? Talks about okay, how did you hear about this program? So now, if I get the result from you, I will be able to. Okay, somebody is helping me here. Thank you very much. So, Mr. Victor, there, please speak up. Speak up. Let's come. Please kindly speak up and make your point. Mr. Victor, can you speak up?
Yeah, can I give an example?
Okay, Miss Favor, you can go on before Mr. Victor is ready.
Okay, now I'm looking at the, like, you talked about weight loss. So I'm
Yes.
looking at weight loss based on three different types of diets.
Good.
So what's the weight loss when the person engages in diet one
Good.
and diet two
Good.
and diet three?
Thank
I
you
think
very
that
much. Thank you very much. That's a good one.
Hello?
Mr. Victor, will you still speak?
Hello?
Yes, I can see. I already dropped a message on the group already.
Yes.
Okay, so for one way and another, you could also consider, let's say, the performance of umbrella using three types of feed.
Good.
You can also say you are looking at the performance of umbrellas using commercial feed and formulated feed.
Okay. Thank you very much. So, Mr.
The
Olishino,
formulated feed is different from commercial feed. So you want to see the performance, what happens at the end of the day.
thank you very much, Mr. Victor. Mr. Olishino,
Yeah,
yeah, you want to say something?
yeah. You can also, yes, you can also use in marketing, like you said.
Okay.
You can use one way and over. Maybe you have a product to sample, three different products to
Okay.
sample. Which of them will the customer prefer?
Okay.
You
Thank you
understand
very
what
much.
I'm saying? Which of the three products? They are the same product with different, maybe different flavor
Or different brand.
or different brand.
Like we
Which
have
of them will
Emzor
customer
paracetamol,
prefer?
Emzor paracetamol. Then we have
Paracetamol,
which other one again?
other paracetamols and other, something like that.
Thank you very much, Mr. Isaac. Can you confirm if you are comfortable with these responses?
Yes, yes.
Thank you
Thank you.
very yeah. Thank you very everyone for the support. So let's quickly move forward. So the next one is the chi-square text, which is the non-parametric text that we have been expecting. So now chi-square wants to help us check the relationship between two categories. That's what chi-square wants to do. And in this situation now, you want to know, for example, if gender influences sport preferences. So in doing that, we can categorize the data as maybe male and female, then sports. So it's kind of wider and broader in reach. And you can see, like I said, like I said before, is we are looking at categorical variable in this situation now. We are not looking at something numerical per se. So let me just quickly mention what the explanation is talking about here now. It says that a chi-square test analyzes the relationship between two categorical variables. It can help determine if there is a statistically significant association between the variable. For example now, we can use chi-square test to examine whether there is a relationship between gender and sport preferences. So you can see now we are looking at gender, a categorical variable. Then we are looking at sport preferences. We can limit the variable to maybe soccer versus football. So in this situation now, we'll be comparing the expected and actual frequencies. So we will test if there is a what significant relationship between the two of them. So when you collect your data, you can ask them to fill the gender, and when they fill the gender, they will now fill the part where they will choose the type of sport they are interested in. For you can control the experiment by limiting the number of sports you want to include. You can control it, yes, it's okay, it's allowed for you to control it by limiting the number of sports you want them to do what you want them to talk about. So from whatever frequency calculations you get, you now be able to determine if males if male prefer more of soccer, or if they prefer more of basketball or tennis, or if female does the other way around. Now it's very interesting because some of these things we are talking about, I remember when I was running my master, we have to do manual calculations for some of these things. And now whenever I see them, and I'll just laugh that look at it, me that we're just back in those days doing manual calculation. I don't know those of us who are running our postgraduate programs now. I don't know if they still bring question on manual calculation for some of these things. Maybe some people will share experience with us. But then with computing, you don't need all these things again. At a click, it will give you all the expected results once you have imputed all the value. So chi-square help us to analyze relationship between categories. So let's use maybe classroom for example. Now you can use classroom for example. You want to find out if um, You want to know the food preferences, maybe a boarding school. You want to know the food preferences between male and female, so that you can be able to know how to ration or make alternative for the different students available. Maybe you notice that most female prefer rice while most male prefer solid or swallow food. Then you could be able to use that data to be able to balance the amount of food you are going to provide for them where alternative is available. But if it's a school where they want to force everybody to eat the same thing, that's totally different. So chi-square test also help us to check relationship between two categories. I don't know if there is any point of call for this chi-square test. Is there any question that we can address quickly before we also move forward? So you can raise, if you have any observation, you can drop it in the chat box. You can drop your comment. You can look at so many things. Okay, thank you very much, Grace. Grace said we can also look at impact of different exercise program on blood pressure. Okay, that's a very good one too. So if there are no questions, I think we can also move forward so that we can really round up quickly with this area. Now, linear regression analysis is, this is one of the bonus that I'm adding in this um, in this cohort. Now, analysis is just to, regression is for prediction of outcomes, and um, from my personal experience anyway, from my personal experience, a lot of researchers will consider those who use regression analysis for their project as top notch. That's just a personal experience. It may differ. It may differ actually. But I noticed that in postgraduate schools, a lot of researchers, and even in the corporate world, because these days they want to be able to predict things and provide solution for averting or enhancing. If it's negative, you avert it. If it's positive, you enhance it or you sustain it. So linear regression analysis is is usually encouraged in most projects because it's a very practical practical, it gives practical solution to product. So we have regression analysis which helps to predict outcome. So linear regression, it predicts a dependent variable based on a single independent variable. For example, predicting income based on years of education. So you want to see years of education or how long this person spent in school. Will it affect the income in the future? You can gather data, and from that data you have gathered, you'll be able to predict if this is true or false. In fact, you can be so accurate when you use advanced data analysis to tell the exact difference that you're expecting and how it's actually going to be like. So that's looking at linear regression. We are looking at one single factor dependent, one dependent factor. Now when you talk about multiple regression, now this predicts a dependent variable based on multiple independent variables. So example, you want to predict house price. What will be the price of a house? And you are going to use that based on size of the house. You are going to look at location of the house, and you are going to look at, is it a new house or a 10-year-old house? You can see that you are looking at different factors, different factors. You can consider more than three factors, and that's why regression is really I won't say it's actually very extremely complex. It's actually complex. In fact, in some situations, those who know how to do coding can develop a model for this, and that project with such we considered as a top-notch project. So that is what regression does. Now when we talk about logistic regression, logistic regression, now this predicts a binary outcome. It will tell you whether it is yes or no, whether this will be successful or it will not be successful. but it will now be based on one or more independent variable. You can see that this one is also extremely technical, because as a data analyst, when company hire you to do things for them or to come and analyze data and be able to predict how they can address some of their challenges, if you are not able to utilize the statistical tools you have very well, you just give them um, inaccurate results, and that could disturb or distort some of the decision they'll be taking in the company or in the institution. So in this situation, you must be very, very vast and solid in order for you to be able to know how you are going to address some of these issues. Imagine a company hire you and you tell them that, okay, oh, if you go on to do this product this way, this way, this way, this way, the outcome will be positive, and in the end the outcome is negative. That would be a very, very um, bad record for such data analysts. So basically, these are some of the tools we'll be talking about in the course of this practical that will start next week. So far so good. I don't know if we have any question from anybody, so that we'll be able to attend to their question. So thank you very much. Okay, sorry, there's something I need to
Thank you.
mention quickly. Sorry, before I finish up, uh, Mr. Olushino, please help us mute first. Let me quickly talk about this level of significance so that we can continue with our question. Very, very important for us to talk about. So now, level of significance in statistics. Now, a level of significance is a probability level at which researchers will decide whether to accept or reject their hypothesis, the null hypothesis. And the common level of significance, we have the 0.05, that's 5%, or 0.01, that's 1%. I think in social science they use 0.05 as the level of significance, but in health, because of the critical nature of health institution, they use 0.01. And what do we mean by that? Look at the example. A 0.05 significant level means that there is a 5% chance of concluding that an effect exists when it does not. It simply means out of 90, if 95 is true, 5 may not be true. That's what it's trying to say. So it's just allowing what we call how do we call it now? It's like you are giving chance for outlier. Say for example now, as a teacher, if you teach your students very well and you put all things together, at least we expect 95% to pass. If 5% do not pass, it shouldn't be considered as your fault. It's a possibility. Maybe there's a special student in the class or something like that. So that's the child. But in health, we want it to be 99%. 0.01%, okay, is okay for 1% because of the critical nature of health. And there are some other area or some other in engineering. I think precision too is very key too in engineering. In fact, engineering will even propose up to 100% because they talk more of precision. So how it works: a result is statistically significant if the level of significance, p-value, is less than the level of significance. So example, in an experiment comparing teaching method, a p-value of 0.03 at 0.05 significant level indicates a significant difference. Let me quickly explain, let me quickly emphasize that. If you do an experiment now, you look at different teaching methods, and maybe in your experiment you are trying to compare, you use teaching method A and teaching method B, and you now carry out a t-test, and from the t-test you take your level of significance to be 0.05, and the p-value is now given at 0.03. So it simply means that the 0.05 significant level is you can say that there's a significant difference. And why does this matter? Because it helps to determine the threshold for accepting or rejecting the null hypothesis. So the significant level will help you to determine if the null hypothesis will be accepted. So the significant level you are looking at must not be greater or must be less than 0.05. Please, I need to emphasize this very well so that we're going to get it. Let me use a different example so that I want everybody to get this point. So let me look at a different example. Can somebody give me an instance where I can use an example for? I think I'm using more of education. Who can help us with a different field that we can give example? Maybe you can just mute or mute your mic and give us um, um, a different field. Who is helping us out? Who is helping us out? Is that are we am I still online? Is everybody still hearing me? Hello?
Yes, sir.
Oh,
Okay.
we can hear you. Yeah.
So I'm talking about level of significance. Okay. Okay, you can mute now. I want us to get it very well because is somebody mic on? Okay. Okay, everybody is on.
Yes. Hello, Mr. Femi.
Okay, thank you.
Hello.
Hello, I'm hearing you.
Hello.
Hello, I'm
Hello.
hearing you.
Yes. So me personally, I'm talking from the field of animal science. So if for yes, if for instance you feed using a formulated diet at the end of the day because it's not a commercial one, and then you want to use it to check for your visceral organs like your lungs, your kidney, and everything, and at the end of the day you find out that these visceral organs have a similar length or the same condition like a normal bed or anything, then you can say that the p-value is not significantly different, like 0.05, showing that okay, there is no effect on the formulated diet that you use, that it's okay. So that's what I can say about that.
Okay. Thank you very much. So I think let's not stress ourselves too much. Let's put it this way. If you carry out an experiment and you are saying out of in this experiment 95% is correct, then I'm okay. 5% you can consider them as, you can say that it should not disturb my experiment or it should not affect my experiment. This 95% that gives me positive result is okay for me to make my conclusion that this experiment is true. I think we can just put it that way. So whatever way you want to bring it in, the idea is this experiment, it is 95% true, then I can make my conclusion based on this that is 95% true. The other 5% that is not true in this experiment should not disturb my experiment or should not disturb me from making conclusion on my experiment. And remember I mentioned it, those in health, I think they are much more concerned. So their own is like 1%. I'm not, I can't, I think I'm sure about that. Yes, just 1%. Okay, thank you very much for that. So there's a question: when do null hypotheses exist? Now you see, when we're talking about research, when you're talking about research, one thing I've learned is you must own your research. What do I mean by that? It is you that is looking out for something. You are the one that is looking out for something. So you will own the research, like it is my research. I am the one that want to add to the body of knowledge. So because I want to add to the body of knowledge, you will decide what you want to add to the body of knowledge, and from there you gather statistical tools, you gather data, and from the data you have analyzed, you'll be able to now choose, or you'll be able to tell that this is the question I have asked and nobody has asked this question before. I am answering the idea of when do null hypothesis exist. You decide it, and that's what your statistical tool will now help you to make conclusion about. So you are the one that will decide the null hypothesis, or you want to decide the alternative hypothesis. Whatever you want to state, it's up to you. Maybe if you have a supervisor, two of you can work it out together. So it's actually all up to you. I don't know if that is fine by you. Thank you very much for that. So, okay, the next question. Sir, they said, what is the range of the p-value? Because we have been talking about values only 0 0.5. What if we have 0.008? So, no, the one we're talking about the generally acceptable standard. Generally acceptable standard. I remember I mentioned it that in social science and in education, we commonly use 0.05 as generally acceptable. Other field may decide otherwise. Like I mentioned, in health, the acceptable standard is 0.01. So you as a researcher, you can tell yourself that I want my research to be exceptionally accurate. So I am going to use a p-value of 0.0001. But remember, it must be realistic. It must be realistic. And that is why they are given the chance. You see, theory is different from real life situation. For those of us who are in sciences, we can understand that very well. At times you get to the lab, what you've been doing from time immemorial, you just get to the lab, the equipment will malfunction, you now look as if you don't know what you're doing. These are factors that make them decide that we don't know what we may expect, so let's give room for what, for this level of significance. I don't know if that makes sense to you. So if we still have more questions, please let's indicate and ask a question. Okay, thank you very much. So I've seen the signal that that makes sense to you. So do we still have any other question? This is 9:17. So normally we should have ended. So but I won't end this class tonight because some of you might have technical issues. Some of you might have technical issues. But I want to emphasize again. Thank you so much. I appreciate the accolades. I want to emphasize again, please. Let's try as much as possible to do our task. There will be two certificates. There will be certificate of attendance and certificate of completion. It is those who completed their task that will get the certificate of completion. But because you are participating, because you have registered for this course, you would surely get certificate of attendance. So, any other question before I move to
Hello,
technical issues? Then we'll call it a day.
hello,
Yes, sir.
hello.
Yes, sir.
Please, can we have notes for today sent to us?
The notes.
Yes.
Okay, and that's why I said I'll move to technical issue. It's already on the shared drive. A lot of people have accessed it already. So I'm going to show us how we can easily access it again.
Okay.
Thank you. Who else have anything to say before I move to technical issues? Okay, so I'm going to stop sharing my screen now. Then we'll move to technical. Okay, I'll still